Oh, hello, guys and gals, and welcome to Unit 4, Part B. So we have just got done with Unit 4, Part A, where we took quadratic equations and we solved them. Now we're going to take those quadratic equations and we're going to graph them. So you need graph paper, you need your calculator, you need a pencil, and you need your notes. We'll get started. Okay, so let's talk about what we've done. So we have graphed lines. Those are called linear equations. We've graphed lines with shading. Remember where we had a line and we shaded one side or the other. Those are called linear inequalities. We have graphed v's. Those are absolute value functions. We've also graphed absolute value functions with shading. Okay, and those are inequalities. So we are going to do some graphing of u's. And eventually, down the road in a couple of weeks, we're going to graph u's with shading. Okay, so it's all part of a connection, all right? So remember all those types of graphing because you got to remember them. All right, here we go. Let's get started with quadratic equations in standard form. So what does standard form mean? Standard form means I have ax squared plus bx plus c. But I'm going to set it equal to y because that tells me that I am graphing, all right? So when I have a y equals there, I am graphing. Now, what do these graphs make? Well, they make a U-shaped, as I've been saying, but that shape is called a parabola. Now, I know it looks like parabola, but it's not. It's parabola. All right, let's go ahead and talk about the key features of a parabola. There's some key features to a parabola. Well, first you have to know that a parabola is a U-shape, okay? Then you need to know that it has a vertex, okay? You also need to know that it has x-intercepts. Now, two more words that mean the same thing as an x-intercept, where it crosses the x-axis, is called a root or a zero. So I may talk about a root or a zero. You may hear that, but you need to know that means an x-intercept. We also have what's called an axis of symmetry. Well, U-shapes look pretty symmetrical, so if I made an axis of symmetry that went down and cut my U in half through the vertex, that would be called my axis of symmetry. All right, now that we have the key features down, let's go ahead and graph a parabola. Now, when we graph a line, we just go ahead and use -2 to 2. But we're not graphing a line. We're graphing a parabola. Do you remember when we graphed V's, we needed the vertex? Okay, well, when we graph parabolas, we also need the vertex. Now, the vertex always goes in the middle of your table. But to get the x value of your vertex, you need to know the equation -b over 2a. Now that should look somewhat familiar because it's part of the quadratic formula. Okay, so we have to figure out what a is, which is 1, and b, which is -4, and we have to plug it into this formula to find out what the vertex, what should we start with? So the opposite of -4 is +4, and 2 over 2 times 1 is 2, and 4 over 2 is 2. And so the x value of my vertex is 2. Now I have a question over here that says, what's my vertex? Well, my vertex is 2. I'm sorry, it keeps doing that. 2 comma something. Well, in order to find my y, I need to find my x first. So this helps me find my x value. Now I plug that in. So 2 squared minus 4 times 2 minus 5. 4 minus 8 is -4, minus 5 is -9. So my vertex is 2, -9. All right. Now, once you find your vertex, you would use values that are below your vertex and above your vertex. So Numbers that are less than 2 would be 1 and 0. Numbers that would be greater than 2 would be 3 and 4. Okay, so now we plug all these values in and get the y. So 0 squared minus 4 times 0 minus 5 equals negative 5. We do the same thing for 1. 1 squared minus 4 times 1 minus 5 would equal negative 8. All right, how about 3? 3 squared minus 4 times 3 minus 5. 3 squared is 9. Minus 12 would be negative 3. Minus 5 would be negative 8. Now, if you're not sure how I'm coming up with these answers in my head, you can take out your calculator and plug them into your calculator. 4 squared minus 4 times 4 minus 5, that would be 16. Minus 16 would be 0. Minus 5 would be negative 5. Now look, this is pretty darn symmetrical, isn't it? Okay, so now we're going to plot these on our graph. 0, negative 5. And we have 1, negative 8. 2, negative 9. 3, negative 8. And 4, negative 5. And now we should be getting a U-shaped graph. Now make sure that you put arrows and make sure that it's a U-shaped, not a V-shape. If you get a V-shape, you did something wrong. Okay, now we're going to answer all these questions that have to do with the parabola. So I got to find my axis of symmetry. Well, I'm just going to go ahead and cut right down. Oops. I'm going to cut right down my vertex and cut the U in half. When I do that, I make this vertical line. Hoivax, remember? Vertical lines are x equals. So my axis of symmetry is x equals, oh, and look where it's cutting. It's cutting right at 2. Okay? Oops. So my axis of symmetry is x equals 2. Now, do I have a minimum value or a maximum value? Well, I believe I have a minimum value because my U shape is like a U, and this is the lowest point. So I think I have a minimum value. If I were to have a maximum value, my graph would be the other way around. Then that would be a maximum point because that would be the maximum height, okay? But in this case, I have a minimum value, and that minimum value is where it touches the y. So if I go over to where it lines up with the y, my minimum value would be 9. All right, now it says, what is my decreasing interval and what are my increasing intervals? Well, intervals are from where to where is it increasing? Okay, so where is this graph increasing? Well, the graph is increasing from negative 9, right here. Do you see this? It's increasing from this point on up. But the interval that I'm talking about is the x values. So the x value that it starts increasing at is 2. Oh, my darn computer keeps doing this. I'm so sorry. So my increasing value starts at 2. And it goes to, oh, look at there. It's going to continue on in an increasing pattern forever and ever and ever and ever for infinity. Okay? And then my decreasing value is going to be from, oh, it decreases. It's going to keep decreasing. Even though my arrow is going up, this is going down because my graph is continually going down and until it hits the minimum. So the decreasing value is going to be negative infinity all the way until I hit 2. Okay? And then my domain for lines was all reals. My domain for V's was all reals. My domain for parabolas are also x such that x equals all reals, because every number on the x is going to be touched from infinity all the way to negative infinity. But my range is not going to be all reals. My range, look at this graph. The minimum value that graph touches is -9. It's not going to go below -9. So the range is y such that y is greater than or equal to that minimum value. So that's my domain and my range. Okay, let's try another one. Okay, this time I'm going to graph y equals -x squared minus 2x plus 8. All right, so I've got to find the x value of my vertex using -b over 2a. So my a is -1, my b is -2. So I'm going to do -b, opposite of -2 is +2, over 2 times a -1, which would be -2, and 2 over -2 makes a -1. So I put my -1 in the middle because my vertex always goes in the middle. And now I use 2 points below -1 and 2 points above -1. So a point below -1 would be -2. Another one would be -3. Above -1 would be 0 and +1. Okay, so my vertex is -1 comma something. So we need to find that y value. So let's go ahead and find all these y values. So I'm going to plug -3 in. Now this is where you're going to make a little mistake every once in a while because of these darn negatives. So we have to do -1 times -3 squared minus 2 times -3 plus 8. Now this is where I would take my calculator and make sure that I use parentheses exactly where it says. I have to have the -3 in parentheses so that when I square it, I get a positive. Okay, so it's -1 parentheses -3 squared minus 2 times -3 plus 8. And that gives me a value of 5. Now let's try -2. So -1 times -2 parentheses squared minus 2 times -2 plus 8. So let's try this again. This time I plug in -2. So -1 parentheses -2 squared minus 2 times -2 plus 8. That gives me 8. Okay, now let's try -1. -1 times -1 squared minus 2 times -1 plus 8. I'm just substituting -1 in everywhere I see. So this -1 times to the power of 2 is 1. 1 times -1 is -1 plus 2 plus 8. That gives me 9. Okay, now I'm going to plug in 0. -1 times 0 squared minus 2 times 0. Anything times 0 is 0. Plus 8 is 8. Now I'm going to type in a 1. -1, 1 squared minus 2 times 1 plus 8. And if you've really figured out this symmetry, because all of these are 1 unit away, and this is 2 units away, -1 to -3 is 2 units away, and -1 to 1 is 2 units away, then this value should be the same as the value up there. And if I did that in my calculator, I would get 5. Okay, and then I'm going to graph these. -3, 5. Okay, I got -2, 8. -1, 9. 0, 8, and 2, or excuse me, 1, 5. There's my U. Whoops, should be a U shape. Okay, and my vertex is -1, 9. And my axis of symmetry, if I were going to cut the U right in half, it would be x equals -1, because that would be a vertical line cutting through -1. Now in this case, like I was talking earlier, this would be a maximum value because that's the maximum height. All right, and that maximum height, if we go over to the y, would be 9. Now, what would be my increasing intervals? Because the U shape is upside down, the graph is increasing on the left-hand side. All right, so here is where my graph is increasing to get to the maximum height, and it's increasing from negative infinity all the way to the maximum value, which is 9. My decreasing interval then is going to start at 9, and it's going to decrease all the way until positive infinity. Okay? And then my domain, like all the other graphs we've worked with so far, the domain is x such that x equals all real values. The range is y such that y, it's not greater than now because it's a maximum value, so the highest it can be is 9, so it's everything 9 and below. So it's less than or equal to 9, just like we did with v's. Okay? Now that's all I have for you. We will see you tomorrow.